are going to skip section 2.5, and not because I just don't want to do it, it's because it's one thing that just has never been in our curriculum. So section 2.6 on rational functions and asymptotes, the first thing you need to know is what a rational function is. A rational number, first of all, is a number that can be written in fraction form. So for example, 3/4 is a rational number because it's a fraction. But what about 0.2? Is 0.2 a rational number?
Yeah.
Can you write 0.2 as a fraction?
Yeah.
Yeah, so it's rational. What about pi?
No.
Pi is not a rational number because you could not ever write, there's no way you can write pi as a fraction. Pi is 3.14, blah, 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 blah. It goes on and on and on and on and on. There's never end to the decimal, so we actually call that an irrational number. Yes?
If you put it over
It's still a decimal over 1. It's not really, that's not a true fraction. A fraction is a whole number over, actually I shouldn't say a whole number. It's an integer over an integer. Yeah, so not a fraction. All right, so same rules apply when we are talking about polynomials. A rational function is, in terms of polynomials, means that you have a polynomial on the top divided by a polynomial on the bottom. So I called the top of this thing n of x. Why did I call it n of x? N for what? Not number. Well, I called the bottom d. Why did I call the bottom d?
Denominator.
Denominator, yeah. And you know what I just realized too, you guys? There should have been parentheses around that. So n of x divided by d of x. N for numerator, d for denominator. This is keep it simple because we're going to need that notation in a little bit here. The domain, you guys have talked about domain before. It's all real numbers except the x values that make the denominator 0. In other words, this rational function will work, always work for any number except when there's any value of x on the denominator that will make it 0, because you can never have 0 on the bottom of a fraction. Yes? Oh, okay. I can't get to you right now, okay? Maybe move on to the next one, or maybe even start looking at the videos for the next stuff, okay? All right. An example of this, f of x is equal to 1 over x. You guys, what value of x will make the denominator 0? That's not a trick question, you guys. What value of x will make the bottom? Okay, good. So the domain is that x can be anything, but if you put an x value of 0 on the bottom of this thing, it's going to make it undefined. So we have a domain that will work for anything, but will not equal to 0. I also wrote that answer in interval notation. It means that anything works. Anything from negative infinity to 0. Notice the use of the parenthesis here. That means it does not include 0. Or it could be anything from 0 to positive infinity, not including the 0. So in other words, anything except for an actual x value of 0. What about the range? The range, same thing. The range is all the y values that will work. Well, the only thing that you're never going to get out of this fraction, 1 divided by x, the only thing that you will never get out of this is an answer of 0. You can get anything, but you will never, ever get an actual value of y. So f of x behavior. Let's talk about some things. And these symbols and notation is stuff that you're going to need if you're going to take calculus next year. So this is kind of a little bit of an introduction to calculus. We're not going to get too deep with it right now, but in this graph, this says as, not 0.5 as some of you thought,
Wow.
as x approaches 0, this little thing right here means left. As the x value approaches 0, here's 0, an x value of 0. As we approach it from the left, in other words, as we are following the graph in and approaching an x value of 0 from the left, what's happening to our function? It's falling down. So, in other words, f of x is approaching what? When it's headed down like that, forever far, what do we call that?
Negative.
Negative infinity, actually. So, and I know these symbols are not fun to make, but if you tilt your paper to the side and just make an 8, that's what the infinity symbol looks like. So it's approaching negative infinity. What happens, though, if you are approaching an x value of 0 from the right? So as I'm coming over here from the right-hand side and I'm following the graph in, what's happening? Where is my graph headed? It's headed up to positive infinity. So in that case, we just do this. You can put a little plus in front of it if you want to, but you don't have to. Positive infinity. What about as the x value approaches negative infinity? So I'm gonna clear here. What happens as the x value is approaching negative infinity? What's happening to the y value? As we're headed this way, what's happening? F of x is approaching what?
Negative infinity.
No, when I say what is f of x approaching, what is f of x? It's approaching 0. Very good. See how it's getting closer and closer and closer to the y value is 0 here. We're getting closer and closer and closer to the x-axis, which really means the value of the function is approaching 0. What happens as the x value approaches positive infinity? So as we are headed to the right, so I follow my graph, I'm talking about x values. What is it approaching?
0.
Again, it's approaching 0. Very good. Does anybody remember, and hopefully you picked up on this already because this word has shown up all over the notes, what are these things called? When we're getting closer to the x-axis from either direction, they're called asymptotes. This thing right here is called a horizontal asymptote. What do you think this thing right here is called?
Vertical.
It's called a vertical asymptote. And I am a horizontal asymptote is written in your notes places, but and so is vertical asymptote. But I'm gonna start labeling these things as HAs. Why?
Horizontal
Horizontal
asymptote.
asymptote.
Okay.
And then this thing right here, I'm gonna label as being a
Vertical aspect.
vertical asymptote, VA.
The house lots.
The Haas and the Vaz, yes. I'm gonna call them the Haas and the Vaz, yes. And actually, I probably will call them Ha and Va. Okay.
Please don't.
Okay, so then I wrote down here that this means that the asymptotes are the x and the y axes. Because as we are approaching the x and the y axes, these graphs are headed up in the direction of positive infinity, or they're headed down toward negative infinity as I approach things from the left and from the right. Okay, so vertical and horizontal asymptotes. The line x equals a is a vertical asymptote. Okay, we need to talk about that. X equals a. You guys, whenever you have an x equals a, what kind of line do you have? What if it's x equals 5? What if this was x equals 5, not x equals a? It would, if it's x equals, it has to cross the x-axis. Yeah. So it's a vertical line. What if it is y equals something?
Horizontal.
Then it's going to be a horizontal line. Very good. Okay, so the line x equals a meaning just some number, some constant value, is a vertical asymptote. If as you approach that a value, the graph is approaching infinity or it's approaching negative infinity. So let me explain to you what I mean. Let's say we have an a value right here. And as you're heading in toward this a value from the left, let's say the graph is doing this. If it's headed up toward positive infinity, that means you have a vertical asymptote right there at a. Does that make sense? What if you're coming in over here from the right and you're headed in like this and it's doing this? It's still headed toward positive infinity. That doesn't mean it has to head toward positive infinity, but in this case it is. What if you're headed in from the right and it's going down toward negative infinity? Well, you'd have a situation like that. The same thing could happen if you were coming in from the left. It could be headed down. If that's the case, you call that vertical line a vertical asymptote. Same thing happens if you are approaching a horizontal asymptote. So in other words, the line, okay, look at this, y equals b. What if it said y equals 2? What does that mean to you? What kind of a line do you have? You have a horizontal line at 2. In that case, you would have a graph looking like this. You'd have a horizontal line right here. And as you are coming in, the graph might be going like this. Or maybe the graph is going like this. See how it's getting closer to that horizontal asymptote? It never touches it, but it just kind of looks like it's gonna crash into it, then it starts to curve, and then it will start to hug that line. And if it hugs that line, that's called an asymptote. It will never actually touch that value. Okay?
It's being tricky.
Alright, asymptotes of rational functions. Alright, here's some important information, especially when we get down here into the Haas of horizontal asymptotes. Vertical asymptotes. Zeros, the vertical asymptotes are always called, they're always the zeros of, what does d of x mean again?
Denominator.
Denominator. The zeros of the denominator are called asymptotes only when the numerator and the denominator have no common factors. And I'll explain what that means in just a minute. So let's say that you have a situation like this. You have a rational function x plus 2 over x minus 3 on the top. It probably won't look like this. You would have to factor it and make it look like that. And then on the bottom, you have x minus 5 and you have x plus 2. Let's say you have this situation. You look at just the denominator. Look at just the denominator. You guys stop writing horizontal asymptote stuff right now. I'll give you a chance to write it down in a second. I just want you listening to this right here. Vertical asymptotes, the VAS. What values of x would make the bottom of this, the denominator, not possible?
5
and negative 2.
Cannot be 5, cannot be negative 2. If you put a 5 in here, you'd have 5 minus 5. You put a negative 2 in here, you'd have negative 2 plus 2. Either of those situations would get you 0 on the denominator, okay? But I said in the definition here, when n of x and d of x have no common factors, are there common factors here?
Yeah.
Yes, what's the common factor?
Positive 2.
Positive 2. So those x plus 2's would cancel out. So really, this is the only situation that's going to give you a vertical asymptote, okay? So we'd only have one vertical asymptote in this case, and that vertical asymptote would be x equals 5. You have something else going on here with 2. When you can cancel them out like that, those x plus 2's on the top and the bottom, when that happens, you're going to have what we call a hole in the graph. There won't be an asymptote. There's just like a break. It's like a little, you will get closer to an x value, as you get closer to an x value of negative 2, there's like a little hole in the graph. It like skips that value, and then it picks up right after. There's a hole in the graph. All right, horizontal asymptotes. Hey guys, this is key. You have to know these things, and you have to be able to use them and apply them. So please make sure if you are one of those people that feel like you don't need to write notes down, this would be something that you definitely need to have down in front of you, okay? Horizontal asymptotes, Haas. I will probably call them Haas. There are 3 situations. 3 situations, make sure you get them down. The first situation says, if the degree of n of x, what does n of x mean?
Numerator.
The numerator. If the degree of the numerator, what is that? What does this symbol right here mean?
Is less.
Is less than the degree of the denominator. There's going to be one horizontal asymptote, and that one horizontal asymptote is going to be at y equals 0. Y equals 0 is the x-axis. Okay? And we will practice this. And so the degree of the numerator is smaller than the degree of the denominator. So let's say you have a situation like this. On the top you have x squared plus 3x minus 1, and then on the bottom you have x cubed plus 4. Do you see that the degree of the numerator is a 2, the degree of the denominator is 3, and if the situation is that, that means you're going to have a horizontal asymptote at y equals 0. In other words, this graph would approach the x-axis. But if the degree of the numerator is exactly the same as the degree of the denominator, there's going to be a horizontal asymptote at y equals You're gonna take the lead coefficient of the numerator divided by the lead coefficient of the denominator. That will be your horizontal asymptote. So let's say you have a situation like this. You have a 2x squared plus 5, and on the denominator, you have, let's do 5x squared minus 7. What is the degree of the numerator? 2. The highest power is 2. What's the degree of the denominator? 2. The degree of the numerator and the denominator is exactly the same. If that is the case, if the degrees are exactly the same, there's going to be a horizontal asymptote at y equals, okay, it says to take the lead coefficient of the numerator. What's the lead coefficient of the numerator, guys?
2.
It's 2. What's the lead coefficient of the denominator?
5.
It is 5. There would be a horizontal asymptote at 2/5, which really means 0.4. There would be a horizontal line at 0.4. If the degree of the numerator, though, is greater than the degree of the denominator, then there's going to be no horizontal asymptote at all. So in a situation like that, you would have maybe like x cubed over x to the, let's say x squared minus 1. If that's the situation, the degree of the numerator is 3, the degree of the denominator is 2. If that's the situation, then there's not going to be a horizontal asymptote. Are you okay with that?
What if they're the same?
What if the degree of the numerator and denominator is the same? If the degree of the numerator is the same as the degree of the denominator, go to situation B.
Come on, Anthony.
You would have, in this case, 2/5. Okay. Anthony fell asleep for a couple minutes, but he's back. He's with us again. All right. Examples. We've got some examples here. F of x equals x squared plus 8x plus 7. And then on the denominator, you have x squared plus 7x plus 10. So we have to find the domain. The domain is, remember, anything except for any x values that will make the bottom of this function 0. So help me out here. We're going to have to factor this. What values, or what can I factor the denominator to? Marcus?
Yeah.
What do you think? What could I do to what can I factor the denominator to?
X plus 17. No. What you could do, x plus 2.
Excellent. So in other words, 2 times 5 is 10. You add 2 and 5 together, you get 7. So what's the domain, you guys?
17.
X cannot be
Negative 2.
cannot be -2, cannot be -5. All right, can't be -2, can't be -5. It's easier to sometimes say what x can't be rather than to say, and x, not usually. Not sometimes. Usually it's easier just to say what it can't be rather than what it can be. All right, Boz. Vertical asymptotes. Remember, you have vertical asymptotes if there is if we've gotten rid of all of our common factors. So what we need to do now is factor the top. What does the top factor to? X squared plus 8x plus 7.
What is that?
Very good. X plus 1 and x plus 7. Are there any common factors? There's nothing on the top that matches anything on the bottom. Therefore, the vertical asymptotes are going to be exactly these factors right here. So we're going to have a vertical asymptote at x equals -2, and then we're going to have another one at x equals -5. Now, if it so happened that we had some factors that would cancel out, then you would have a vertical asymptote at only the leftover on the denominator. Does that make sense? We did this last year, so this should be a little bit of repeated information. You weren't there that day. I'm just talking to Michael. Michael's looking at me like I never taught him this. It's just horizontal asymptote. Horizontal asymptote. Go back to your 3 rules that I said. Make sure you have these written down. Make sure you have them written down. So what is the degree of the numerator? the degree of n of x is equal to 2. What about the degree of the denominator? It's 2. And whenever the degrees are exactly the same, that means you have a horizontal asymptote at y equals what? Look at your notes. The lead coefficient of the numerator is 1. The lead coefficient of the denominator is 1. 1 divided by 1 is, so we have a horizontal asymptote at y equals 1. You okay with that?
Yes.
All right. Okay, let's try the next one. All right, the domain. So we factor the bottom. What does the bottom factor to? You have an x squared, that's a perfect square. 9 is a perfect square. So what's it going to be? Very good. X plus 3, x minus 3. You should be good at recognizing that now. X plus 3, x minus 3. The top is already factored. So do I have anything that cancels out? The top and the bottom. Anything cancel out?
No.
No? Are you with us? Promise?
I know.
The domain then is that x cannot be what? Cannot be negative 3, cannot be positive 3. Vertical asymptotes. Well, since we have nothing that cancels out with the top, that means I'm going to have vertical asymptotes at exactly the same thing. So we have x equals negative 3, and we have an x equals 3. Now we need to talk about the horizontal asymptote. The horizontal asymptote, that's when you have to go back and check the degree of the numerator, the degree of the denominator. What's the degree of the numerator?
1.
The degree of n of x is equal to 1. The degree of the denominator, d of x, is equal to what? 2. And whenever the degree of the numerator is smaller than the degree of the denominator, that means that you are going to have a horizontal asymptote where?
0.
At 0. At y equals 0. Very good. Okay. So in other words, the x-axis in this case would be the horizontal asymptote. Let's see, what do I have? 2 more examples, you guys? 3 more examples? All right. Okay, number 3. I actually don't know if we're going to do the last example together. F of x is equal to x to the 4th power plus 2 over x cubed minus 9x squared minus 10x. The domain. Well, you guys are used to just factoring them and figuring out what values of x would not work. But in this case, that's not easily factorable, the way we have been factoring it. But what do you recognize that they all have in common? They all have an x. What I'm going to do is this. I'm going to take an x out. So in other words, I'm dividing an x out of each one of these terms. And when I divide an x out of each one of those terms, what am I left with for the first term? X squared. I divide an x out of this one, I have minus 9x. Divide an x out of that one, I'm left with minus 10. All right, but I can factor this more. This x squared minus 9x minus 10, that can be factored. So I'm going to say equals x times, now help me out here, what 2 numbers multiply to give you negative 10, and we'll add together to give you negative 9.
Negative 10 and 1.
A negative 10 and a positive 1. All right. The top. Does the top factor? X to the 4th power plus 2. It doesn't factor. So we're not going to have anything on the top that matches anything on the bottom. So our domain is that x cannot be what?
10 or negative.
Can't be 10. It can't be a -1, but it all, what about this thing right here? Whenever x was alone, and then 0. So it can't be 0 either. It can't be 10, can't be -1, can't be 0. Vase. Remember, nothing cancels out with the top and the bottom. So we have vertical asymptotes. We have VAs at 10. We have another one at -1. And then we have another one at 0. So in other words, our vertical asymptotes are exactly the same as what our domain could not be. Horizontal asymptotes. Well, horizontal asymptotes, remember we need to check the degrees. What is the degree of n of x?
4.
The degree of n of x is 4. What about the degree of the denominator?
3.
Degree of the denominator is 3. And whenever the degree of the numerator is greater than the degree of the denominator, that told you that you were going to have a horizontal asymptote where?
0.
Don't have one at all. Yeah. So there is no horizontal asymptote. None. There's no horizontal asymptote when the degree of the top is bigger than the degree of the bottom.
Can I finish the notes on the top?
Pardon me?
Can I finish the notes on the top now? Notes on the inside? Goodbye.
Okay, number 4. Domain, let's back to the bottom. This right here, remember, means a -1. So we have x, and x. What two numbers multiply to give you -12, and when you add them together, you get -1. X
-4.
-4 and x plus 3. So our domain tells us that x can't be +4, cannot be -3. And now we need to see if anything cancels out with the top. So help me factor the top. What does the top factor to? And it is factorable. 3 and 1.
So over 3.
So we have, the 3's cancel out. So we have an x plus 3 and we have an x plus 4. So since the 3's cancel out, we only have one factor left on the bottom, so there's going to be a vertical asymptote at 4. So our domain was both things that made the bottom 0, both numbers that made the bottom 0, but there's a vertical asymptote at only the leftover. Okay? But I also want you guys to make a note here, put a big old note here, that there is going to be a hole at where?
3.
At 3. Actually, no, not 3. At -3. There's going to be a hole at x equals -3. It is not an asymptote. It's just a small break in the graph. Horizontal asymptote. The degree of the numerator is what?
2.
2. The degree of the denominator is 2. What does that tell you?
It's going to be a 0.
The lead coefficients. So we have y equals, what is the lead coefficient of the numerator? It is 1. The lead coefficient of the denominator is 1. So you are going to have a horizontal asymptote at 1 over 1, which is 1. You have one horizontal asymptote that's at y equals 1. Okay, I think we're going to stop there. Number 5 is a little tricky. I want you guys to practice the other stuff first, and we'll talk about number 5 another day.